Why haven't we found extraterrestrial life? This is a question that has puzzled scientists and astronomers for decades. As we gaze into the vast cosmos, the silence is deafening. Where are the other voices in this grand theater of existence? This burning question has given birth to intriguing theories, each painting a unique picture of our universe and our place within it. Let's journey through the intriguing realms of the Fermi paradox, named after the Italian physicist Enrico Fermi, who famously asked, "Where is everybody?" Then there's the Great Filter theory, suggesting that life's path to the stars may be barricaded by insurmountable challenges. The rare Earth hypothesis posits that life, as we know it, is a cosmic rarity, a precious gem in the vastness of the universe. Lastly, we'll explore the chilling we are alone hypothesis, the notion that we might indeed be the only conscious beings in this cosmic sea. Each of these theories tries to answer this burning question, so let's delve into each one to understand better. Named after Italian physicist Enrico Fermi, the Fermi paradox asks, if extraterrestrial life exists, where is it? This profound question has been at the heart of scientific debate for decades. The Fermi paradox isn't just a question, but a theory that seeks to explain the silent universe around us. The paradox itself is a conflict between the high-probability predictions for extraterrestrial life and the apparent lack of evidence or contact. With billions of stars in our galaxy, each potentially hosting habitable planets, the silence seems statistically improbable. One explanation offered by the Fermi paradox is that these civilizations could be so far away from us that our signals haven't reached them yet, or theirs haven't reached us. The vastness of space could be acting as a cosmic barrier, isolating civilizations from one another. Another aspect of the Fermi paradox suggests that extraterrestrials might have technology far more advanced than ours. They might be communicating in ways we can't even begin to comprehend. Just as we wouldn't hear the radio signals of an alien civilization using technologies beyond our understanding, they might not perceive our attempts at contact either. As we continue to evolve technologically, this part of the paradox might resolve itself in the future. But the Fermi paradox also has its critics. Some argue that it makes too many assumptions about extraterrestrial life, its technological progress, and its motivations. The paradox assumes that all intelligent life would want to explore and colonize the galaxy, but this might not be the case. The Fermi paradox is a fascinating thought experiment that forces us to confront the possibility of our solitude in the cosmos. Its strength lies in its ability to challenge our assumptions about life beyond Earth and to spur us on in our search for answers. The paradox doesn't provide a clear solution to the question of extraterrestrial life, but it does underscore the importance of continuing our exploration and research. The Fermi paradox leaves us with more questions than answers and pushes us to continue our search. The Great Filter theory suggests that extraterrestrial life might have encountered obstacles preventing them from becoming technologically advanced. This theory, in essence, raises an eyebrow at the eerie silence of the cosmos, suggesting that it's not the absence of life that's puzzling, but the lack of advanced civilizations. The Great Filter is a term coined by economist Robin Hanson, and it pertains to a hypothetical barrier or series of barriers that life must overcome to achieve interstellar communication capabilities. These barriers could be anything from the difficulty of life forming in the first place to the challenges of developing multicellular organisms, all the way to the potential self-destruction of advanced civilizations. Imagine for a moment the process of evolution as a colossal obstacle course. The hurdles in this course represent the various stages of development life must navigate through. From the inception of life, evolving from single-celled to multicellular organisms, developing intelligence, and ultimately achieving a technologically advanced state capable of interstellar communication, each stage presents its own set of challenges. However, the Great Filter theory isn't just about life's struggle to reach the stars, it also harbors a more ominous implication. If the Great Filter lies ahead of us, instead of behind us, it means that our civilization is yet to face a significant challenge that could potentially wipe us out. This could be anything from a catastrophic natural disaster, a devastating war, or even an unforeseen consequence of technological advancement. Critics of the Great Filter theory argue that it may be overly pessimistic, assuming that life's development is inevitably marred by disasters. Others suggest that advanced civilizations might choose isolation or communicate in ways we can't yet comprehend or detect, which doesn't necessarily imply a universal filter. While the Great Filter theory might seem pessimistic, it encourages us to consider the hurdles that life might face in the universe. It's a stark reminder that the road to progress isn't always a smooth one, and that the silence of the cosmos might be telling us more than we think. The rare Earth hypothesis proposes that, while extraterrestrial life may exist, it is extremely rare. This notion has its roots in the understanding that the conditions for life as we know it, those very conditions that exist here on Earth, are not just complex, but exceptionally unique. It's like finding a specific grain of sand on an endless beach. Firstly, consider the distance between planets. The vastness of space is mind-boggling. We reside in a galaxy that's over 100,000 light-years across, housing billions of stars, each potentially with its own set of planets. Yet, the distances between these celestial bodies are staggering, making the chances of finding a life-sustaining planet like finding a needle in a cosmic haystack. Next, the composition of planets comes into play. Not all planets are created equal. Our Earth is a veritable Goldilocks of a planet, with just the right size, the right composition, and the right distance from the sun. It's not too hot, not too cold, but just right for liquid water to exist, a fundamental requirement for life as we know it. The environment of planets provides another layer of complexity. A planet might have the right size and the right distance from its star, but what about its atmosphere, its magnetic field, its geological activity? The list of requirements for a planet to sustain life is long and intricate. However, the rare Earth hypothesis is not without its critics. Some argue that life may be more resilient and adaptable than we give it credit for, capable of thriving in conditions that we would find inhospitable. Others point out that our understanding of life is limited to our own Earth-centric perspective, and that extraterrestrial life might not adhere to the same rules. The rare Earth hypothesis reminds us of the exceptional and unique conditions required for life as we know it. Whether it discourages or motivates us in our search for extraterrestrial life, it certainly highlights the miraculous confluence of factors that led to us, here on this pale blue dot we call home. The "we are alone" hypothesis takes a bold stance by suggesting that Earth is the only planet in the universe with life. This is a viewpoint that dares to stare at the vastness of the cosmos and declare that, despite the seemingly infinite number of stars and planets, we are it. A solitary island of life in an immense cosmic ocean. This hypothesis does not dismiss the possibility of life out of hand, but rather asserts that the conditions necessary for life as we know it are so specific, so exacting, that they have only occurred once, here, on Earth. It's a theory that's grounded in our current understanding of biology and astrophysics, but it also acknowledges the limits of that understanding. What are the pros of this theory? Well, it offers a simple answer to the Fermi paradox. If we're alone, then of course we haven't found anyone else. It's perhaps the ultimate Occam's razor approach to the question of extraterrestrial life. On the flip side, the cons are perhaps more philosophical than scientific. If we are alone, it means that life is an incredibly rare, perhaps unique event. It implies a loneliness on a cosmic scale, and for many, that's a chilling thought. But let's look at the implications of this hypothesis. If we are indeed alone, it places a tremendous responsibility on us. Not only are we the stewards of life on this planet, but we become the custodians of life in the universe. It raises the stakes for how we treat our planet and each other. It also underscores the importance of our exploration of space. If we're the only life there is, then every step we take into the cosmos is a monumental moment in the history of life itself. The "we are alone" hypothesis, while lonely, makes us appreciate the uniqueness of life on Earth. It reminds us that life, in whatever form it takes, is a marvel. A precious, fragile, and perhaps solitary flash of complexity and consciousness in the vast, silent expanse of the universe. Despite the theories, the search for extraterrestrial life continues. The Fermi paradox posits the possible existence of civilizations far more advanced than ours, while the Great Filter suggests that some cosmic hurdle could hinder life from evolving to a technologically advanced state. The rare Earth hypothesis claims that life may exist, but it's just incredibly rare due to a myriad of factors like distance, planetary composition, and environmental conditions. The "we are alone" hypothesis, on the other hand, confronts us with the potential reality that Earth might be unique in nurturing life. Our current technologies, the vast complexity of the universe, and the element of chance all present challenges in our quest for extraterrestrial life. Yet with every passing year, our abilities grow, and our understanding of the cosmos deepens. While we have yet to find definitive proof of extraterrestrial life, the search continues to inspire us and push the boundaries of our understanding of the universe.